All right, welcome. This is chapter 2 of our last unit D review. We're doing something a little different this time. I'm going to make a little chart as we go, but we're going to look at all the different energy sources that we use for electricity or that can be used for electricity. We're going to look at where the original source of this electricity is coming from, the advantages and the disadvantages of each of these sources. So I've got a few things already set up here. We've got our sun, and we know that the reaction in our sun is fusion. And that fusion reaction, let's just write out real simplified version of it, is hydrogen plus a hydrogen is coming together to create helium. Super simple. I didn't use nuclear notation, right? But the idea of two hydrogen atoms combined to form helium, that's what's happening in the sun. And as that happens, a whole lot of energy is given off and emitted as electromagnetic radiation to get all that heat and solar radiation. And this is driving a lot of our different energy sources, as you're going to see. So the first electricity source that we're going to take a look at, and I'm just going to use a different color, is fossil fuels. Number one, we're going to look at fossil fuels. And I would suggest this is a good review to actually have it on a piece of paper. You can draw along as we go together, and then you have this chart because there is no print review for this section that you can just print off. So you'll have to be taking a look at this. So fossil fuels. So when we're talking about fossil fuels, we are talking about coal, oil, natural gas. And all of these fuels originated from animals and plants. So you had some plants growing here, maybe by the lake or the ocean. You had some animals munching on these plants, and you have to bear with my animal drawing. So you had some animals munching on these plants. They die, obviously. Maybe a mudslide came down. They got covered with rocks, sediment. Over time, the pressure builds up. So there's pressure too. And then they turn into fossil fuels down below the earth. Okay, so the earth's built up on top of them. So we've got fossil fuels down there like coal, natural gas, oil. Okay. So all of these fossil fuels, we can drill to find them, dig, whatever we need to do to get to them. And so if you look at like the original source of these fossil fuels, coal, oil, they are all possible because of our solar energy. So from our sun, that solar energy was used to grow those plants. So solar energy from the plants to grow, it was converted into potential energy within the plants, or chemical potential energy. And that chemical potential energy is stored in the plants and animals and transferred to the animals. Then it's underground, and then we dig it up. And then what do we do with it? We burn it. All right, so this is a key piece here. So let's just take a look at what a coal-fired plant or a plant that's going to use one of these fossil fuels to create electricity. You're going to take that chemical potential energy and you're going to burn it, right, with our combustion reaction. Combustion. All right, and when we're doing that, we're heating up water to create steam. Steam is the key here. Steam, but we're trapping that steam and we're using it to turn our turbine, which is attached to our generator. And it's the generator that is creating the electricity. So that chemical potential energy is released as steam to turn the turbine, and this is the kinetic energy here because things are moving, right? Turbine is moving, steam is moving. Then we have our generator and turning it to electrical energy here. I'm drawing this pretty big because this is used quite a few times, right? A lot of our different energy sources use this same deal. So let's just highlight for fossil fuels, pink. Oh, maybe I highlighted, yeah, fossil fuels. And we have solar energy, going to chemical potential energy, to kinetic energy, to electrical energy. And there's your pathway for fossil fuels. Covered that up a bit. All right, so if we go back and we take a look at the original energy source for fossil fuels, the original energy source is the sun. And what's happening in the sun? It's a nuclear reaction. Okay, so that's our source of all fossil fuels. All right, so advantages of using fossil fuels. Right now, they're cheaper and plentiful, especially here in Alberta. Got lots of them. Unfortunately, they are non-renewable, so they will not last forever, and they can't be renewed fast enough in our lifetime. They also release carbon dioxide, sulfur dioxide, which we know carbon dioxide causes climate change, global warming. And sulfur dioxide leads to acid rain or acid deposition. We also know there are particulates that are released too. Whoa, particulates, and these can lead to smog and air pollution. So lots of issues with our environmental issues for disadvantages. Alrighty, also the mining too. There's mining involved here. And that can cause damage to our environment. Okay, so the next source of energy we're going to look at is nuclear. Number 2. All right, and where is nuclear energy coming from? Well, we are mining for, let's say we're mining here, uranium. Okay, all the uranium that we have on Earth was created billions of years ago. So again, this is considered a non-renewable resource. I'm going to do this in a green so we can keep them separate from one another. Okay, so nuclear, number 2. So disadvantage, it is non-renewable. Okay. Advantages for nuclear is they don't give off emissions, or very little. Depends where you look. Alrighty, so what's happening with this uranium, or molecules similar to uranium, is that they are going through fission reaction where mass is lost, right? Remember Einstein's formula? Mass is lost and transferred to energy. And that's where the energy is coming from. The original source is from a fission reaction, and it's the mass that's turned into energy. So that's our original source. Okay. Other advantages. You did a whole project on nuclear, so you probably remember that there's lots of energy released from these type of reactions. But building the structures we need for these, the factory, oh gosh, I can't remember that. Sorry, they're very expensive. They're costly. Okay. Also, we have all that radioactive waste that's with us for thousands of years. Radioactive waste. Also, there's the worry of the waste might feed nuclear reactors, weapons. There's also the worry of accidents that are deadly and destroy whole areas with the radiation that they can release. Okay. Yeah. Okay. So that's probably the key stuff for nuclear. Oh, one more thing. Yeah, sorry. From that nuclear fission reaction, we're going to take that energy, and this is where we jump right in at this point, where that energy, instead of burning like combustion, it's heating up the energy, turning a turbine, turning a generator to create the electricity. So this nuclear reaction is jumping right in at right at this next spot in our electrical generation part. Okay, let's find another color. We're on to hydro. Well, since it's hydro, let's do blue. Okay, so number 3 is hydro. How do we use water to create electricity? Alrighty, so the water cycle is driven by our sun. Our solar energy, here it is coming in. It is going to hit this water and cause the water to evaporate. And as it goes up, that water gains potential energy from its height. Potential energy. Now it's hanging out in the clouds. It's going to fall down. Well, okay, let's move the cloud over a bit, and then it's going to fall down. Precipitation happens. That potential energy is coming down here in a river, and we're going to dam it. So we're going to make ourselves a dam. Back that water up. Now we're harnessing this potential energy behind the dam. As we let it out, we pop. I'm going to put it here, right here. This is where we're going to put our turbine. And we're going to use our turbine to get the water to turn our turbine, which turns the generator. Again, same pattern, turbine turns the generator to create the electricity. But this time we don't have to burn anything. There are no emissions, no harmful emissions. So I'm going to write that down, no emissions. It can create lots of energy, actually, from these hydro dams. They can work 24 hours a day, too. There's no stop time to them. They are costly to build, too, these big structures. And they do, as you saw with that Three Gorges one, they displace people. They can displace people, wildlife, and they can damage the environment that way. Okay, so the original source of hydroelectric power, you got to look back to the sun, because it's the sun that's driving the water cycle that gets that water up the mountain so that it can run downhill. So the original source, again, is that sun, that solar energy, that heat that's created by the nuclear reaction in the sun. All right, on to the next one. So now we're going to take a look at tidal. Let's go with that color. There we go. So number 4. We're going to see if we can squeeze all this on one page. This will be a feat. So tidal power for generating electricity. You hopefully remember that tides are caused by the moon and the earth interactions, right? So it's a gravity and the sun a little bit too. And but mostly the moon, and it's the gravitational potential energy, right? That gravity is pulling the water to create the tides. That's how you get tides. Without the tides, we don't have tidal energy. So because we get the tides, we get the water moving, and the water moving is kinetic energy. And we're going to harness that water moving by popping, you guessed it, a turbine in here. So we have our turbine hooked up to a generator. And then we're pumping out the electricity, electrical energy. Okay, so basically our tidal energy starts right at this point in the process above here. So we don't have to burn anything either for tidal energy. So the original source is the moon, Earth, and I might even put sun in there. Interaction, gravitational pull. Okay. Advantages, this is renewable. Tides are here as long as we are. There's no emissions. It is expensive for what you get. It's not consistent, like you're only going to get movement of the water 4 times a day. Not consistent. It does disrupt habitats under the ocean floor, and it can only be used in very specific locations. Alrighty. Okay, moving on to the next one. Let's go with that color. I don't know what that is. Okay, number 5, wind. Wind. All right, so, oh my gosh, I don't have a lot of spot on my land here anymore. Okay, well, my land is I'm gonna have a nice big wind turbine on the edge of this mountain in the foothills. Funny that. That's kind of weird. Okay, well, that's a really sad looking turbine. Okay, but this is my turbine. Wind turbine. Okay, so how is this happening here? So its original source, so the wind, we need wind. How's wind created? It's the same solar energy coming down to the earth. It warms it up, so you've got thermal energy. Thermal, heats up the air molecules and gets those air molecules to move. Okay, and that's kinetic energy. When you have movement, you've got kinetic energy. Wind. Alrighty, the wind comes, it turns the blades of our turbine. Right, here's a turbine, which is connected to a generator to produce electricity. So it can all be done in one spot here. So turbine, generator G to electrical energy, electricity. Alrighty, so the original source is wind, and wind's original source is back up to the sun. We would not have sun without the wind. So the sun creates that wind. All right. What else we got? Okay, so advantages. It's renewable. We'll always have wind. Unfortunately, we don't always have wind, right? So it fluctuates. So I'll put that as a disadvantage. Fluctuates. No emissions, though, is an advantage. No emissions. And they're really easy to install. Easy. So you could put one of these on your property, and you can hook it into the grid relatively simply. And it's not too expensive. It's not like building a whole station or something. Okay, so yeah, it fluctuates, it varies. Some people don't think they look very nice, so they could be considered an eyesore, although I wouldn't say like a coal-fired plant is very pretty either, but these tend to be more in your backyard, so you'll be seeing them NIMBY, so you get that NIMBY effect, not in my backyard, which we talked about. Also, there's definitely some cases where they've killed birds, so have to take that into account as well. Alrighty, so that's wind. Let's move on to the next one. Let's go here. Okay, the next one we're going to look at is using solar voltaic cells. Solar voltaic cells. Sorry, they're photovoltaic cells for solar. Alrighty, I'm going to have to stick my solar panel up here and catch the sun. Here's my solar panel. Solar panels are a quick conversion. They take that light energy from the sun, so that light, and they directly turn it into electrical. So there's not very many energy changes when you're dealing with a photovoltaic cell. All right, it's basically light right to electrical. So there's only one conversion, so it's quite efficient that way. So we can call that an advantage. They're efficient. But they also disadvantages. They only work when sun's out. When sun out. So you need a battery to store in between. So they're variable. They can be expensive, but the price is coming down. Advantages, though, they are easy to use. Again, you could put these on your own roof and hook into the electrical grid. Where is the original source? It is the sun again, the nuclear reaction going on in the sun. So those are both nuclear reaction in the sun. It's fusion. Alrighty, next one that we looked at is, what do we got? Geothermal. Okay, so yeah, we're not doing these actually in the order that we looked at them, but that's okay. Geothermal. So geothermal, this is when we are going to use the heat that's from the center of the earth. So we got heat in here. This heat is due to a nuclear reaction in the core. Reaction. And these are decay reactions in the core. And these are here for a long time. So we can consider these a renewable source. If these stop, we probably won't be existing anymore. So we can dig down, use this heat. So we use the heat. I'm gonna have to squeeze this in. Heat, that's thermal energy from the core to create steam, and then turn a turbine, generator electricity. Okay, so here again, we're popping in right here, but instead of burning something, we are using the nuclear reaction that's happening in the core to heat our steam. Okay, so the original source is going to be the mass that's lost in the nuclear reaction. So we've got a nuclear reaction inside the core. So we can say nuclear reaction Earth core. Okay. Some more advantages. No emissions. Well, okay. No, actually, there were some emissions. That's not true. So there are some emissions with there's some carbon dioxide, also some other I think methane, sulfur. So there are some, but nowhere near as much as carbon dioxide, but there are emissions. So there are emissions. We better put that under a disadvantage, but smaller. We'll see. So there are emissions, but there's less of them. They have, a lot of times they have to be in specific locations, but that's getting less important. Location. They have to go, you have to dig deep too to use these. Okay, but advantages is it's going to always be there too. It's not variable. It's always present. Always present. I did not spell that one right. Okay, we got one more. I think we can squeeze it in here. Let's find another color. Brown. I haven't done brown yet. Alrighty, so number 8. This is our hydrogen fuel cell. Okay, so this is creating electricity for the car, but you could also use it for other purposes. So when we have a hydrogen fuel cell, I'll just draw like a little, here's a box. There's my hydrogen fuel cell. Awesome. So what do you need to input? You need to put in hydrogen gas, and you need to put in oxygen gas. You also need to have a catalyst. And your thing that you get out of this is obviously electricity, which which is awesome. And then the only other emission that you get out is water. So you go along and you drip water out of the back of your car. That's all right. All right, so that's a hydrogen fuel cell. So a lot of the advantages, disadvantages, original source are going to depend on where you get this hydrogen from. Hydrogen is not sitting around like that for us. So we usually have to take hydrogen, either we have to break water apart and use electricity to break it apart to get hydrogen, or we can take the hydrogen off fossil fuels, different types of fossil fuels we can use to get that hydrogen off. So there can be emissions in where you get the hydrogen from or how you get the hydrogen. So there can be emissions depending on hydrogen source. But there's no emissions at the actual fuel cell site, but not at site of fuel cell. So where you're actually using the fuel cell, the only emission you're getting is the water. Okay, so the original source of the hydrogen is going to depend. Okay, and that's just going to depend on where you're getting the hydrogen from, where H2 is from, or where the electricity to get the H2 is coming from, right? So there's too many things. So the advantage, there's no emission at source. Okay, so that's no emission at the actual source of this. One of the disadvantages is the infrastructure to use this in a vehicle has to change, would have to dramatically change. So instead of going to the gas station to fill up your car, you would have to be getting hydrogen into your vehicle. So if we're going to use this in vehicles, we need a whole different infrastructure, not only in the vehicle, but also in like the filling up stations. Okay, that is my overview of the different types of energy sources that we looked at and how they create electricity, where the original source is for that electricity, advantages and disadvantages. Have that in a chart somewhere. This is a beautiful picture. I'm going to see if I can take a screenshot of it before I finish off. And then, yeah, that is the review of chapter 2. Make sure you try lots of different practice questions because I think that's where you're really going to figure out if you understand this material. Have a good day.